Welcome to Math Contest Drills for Filipino Kids. In this presentation, let us answer some problems involving arithmetic and geometric progression. Let's begin with question number 1. What is the defining function of the sequence 2, 5, 8, 11, 14, 17, and the pattern continues? Using the function, find the 15th term. Here is our suggested solution. From the given sequence, we can say that there is a common difference. Each term is obtained by adding 3 to the previous term, hence this is an arithmetic sequence. So to find the defining function for this sequence, we will use the nth term for an arithmetic sequence. That is, a sub n is equal to a sub 1 plus n minus 1 times d. From the given sequence, a sub 1 is equal to 2, and the common difference can be obtained by subtracting each term by the previous term. We have 5 minus 2 is equal to 3. Also, 8 minus 5 equals 3. So we can find the defining function substituting a sub 1 equals 2 and d is equal to 3. We have a sub n is equal to 2 plus n minus 1 times 3. Simplifying, we have 2 plus 3 times n is 3n. 3 times negative 1 is negative 3. So a sub n is equal to 3n minus 1. We have 2 minus 3, that's negative 1. To find the 15th term, that is n is equal to 15, so a sub 15 is to substitute n equals 15 to the defining function. We have 3 times 15 minus 1, and this is equal to 45 minus 1, that's 44. The answer, the function is a sub n equals 3n minus 1, and the 15th term is 44. Problem number 2, the 6th term of an arithmetic sequence is 27. If the 12th term is 45, what is the first term? For our suggested solution, we're going to use the formula for the nth term of an arithmetic sequence, and we will be producing two equations for this problem, and we will solve them simultaneously. From the second statement, the 12th term is 45, so we have a sub n, or a sub 12 is 45, and this is equal to a sub 1 plus n minus 1. Since this is the 12th term, n is equal to 12, so 12 minus 1 is 11 times the common difference. Let us call this our equation 1. From the first statement, the 6th term is 27, so this is a sub 6 equal to a sub 1 plus, since this is the 6th term, n is equal to 6, so 6 minus 1 is 5. We have 5 times the common difference. Let us name this our equation 2. Let us solve these two equations simultaneously using elimination. Then we subtract the two equations term-wise. 45 minus 27 is 18. A sub 1 minus a sub 1 is 0. 11d minus 5d is 6d. Dividing both sides of this resulting equation by 6, we will get d is equal to 3. Let us use equation 1 to solve for the first term. We have 45 equals a sub 1 plus 11 times the common difference, which is 3. So we have 45 is equal to a sub 1 plus 33. Then we have 45 minus 33, using addition property of equality. We get a sub 1 is equal to 12. Number 3, what is the value of k if 6 minus 2k, 3k plus 1, and 5k form an arithmetic progression? Here is our suggested solution. For this problem, we're going to use the definition of an arithmetic progression, where each term is obtained by adding a common difference or a certain value to the previous term. Then, if these three terms form an arithmetic progression, we have the second term, which is 3k plus 1, minus the first term, which is the previous term, 6 minus 2k. This difference must be equal to the difference between the third term, which is 5k, and the second term, which is 3k plus 1. Let us simplify this equation. 3k plus 1 minus 6 plus 2k equals, on the right hand side, 5k minus 3k minus 1. Then we have 5k, that's 3k plus 2k, minus 5, that's 1 minus 6. On the right hand side, 2k minus 1. Subtracting 2k from both sides and simultaneously adding 5 to both sides, we have 5k minus 2k is equal to 5 minus 1. 5k minus 2k is 3k, and 5 minus 1 is 4. So we can get the value of k by dividing both sides of this resulting equation by 3. We have k is equal to 4/3. Number 4. How many terms are there in an arithmetic sequence if the first, second, and last terms are 10, 14, and 106 respectively? For our suggested solution, let us first get the given information. We have the first term equals 10. The second term equals 14. And the last term, let's name it a sub n, equals 106. Let us use the formula for the nth term of an arithmetic sequence. And since we're given the first term and the second term, and this is already known to be an arithmetic sequence, then we can get the common difference to be a sub 2 minus a sub 1, that is 14 minus 10, then the common difference is 4. So let us substitute a sub 1, a sub n, and the common difference to the formula for us to be able to get the value of n. We have 106 equals a sub 1. A sub 1 is 10 plus n minus 1 times the common difference 4. Subtract 10 from both sides, we get 96 is equal to n minus 1 times 4. Then dividing both sides by 4, we have 24 is equal to n minus 1. Then we add 1 to both sides, we'll have n equals 25. So there are 25 terms in this arithmetic sequence. Number 5. What is the 20th term of an arithmetic sequence given its 4th term as 79 and its 9th term as 54? Let us use the previous solution. We'll have two equations for the given information. We have 54 as the 9th term. So we have 54 is equal to a sub 1. Since this is the 9th term, we have 9 minus 1. That's 8 times the common difference. Let's have this as equation 1. Also, we are given 79 as the 4th term. We have 79 equals a sub 1 plus 4 minus 1 is 3 times the common difference. Again, let us subtract these two equations term-wise. We have negative 25, that's 54 minus 79, equals a sub 1 minus a sub 1 is 0, 5d. Dividing both sides by 5, we have d is equal to negative 5. Let us solve for a sub 1 using equation 1. We have 54 equals a sub 1 plus 8 times negative 5. Then we have 54 equals a sub 1 minus 40. Adding 40 to both sides, we have a sub 1 equals 94. Then we can solve for the 20th term, that is a sub 20 is equal to 94 plus 20 minus 1, that's 19, times negative 5. That's the common difference. So we have 94 minus 95. Hence, a sub 20 is negative 1. Number 6. The sequence 3, 1, 1/3 and the pattern continues is geometric. What is the common ratio? Hence, what is the defining equation? Let us begin by solving for the common ratio. We have a sub 1 equals 3, a sub 2 equals 1, and a sub 3 equals 1/3. Since this is a geometric sequence, we can solve for the common ratio by getting the quotient between two consecutive terms, that is a sub 2 over a sub 1, and we can verify this by looking at the quotient between a sub 3 and a sub 2. If they are the same, then this is the common ratio. So we have a sub 2 is 1, a sub 1 is 3, then the common ratio is 1/3. Let us check by looking at the quotient between a sub 3 and a sub 2. That's 1/3 over 1. These two are equal, therefore the common ratio is 1/3. Let us identify the defining equation using the nth term of a geometric sequence or progression. A sub 1 times r raised to n minus 1. Hence, a sub n is equal to a sub 1 is 3 times the common ratio 1/3 raised to n minus 1. Next number. Find the 10th term of a geometric sequence, negative 8, 4, negative 2, and the pattern continues. We're just going to use the formula for the nth term of a geometric sequence, which is a sub n equals a sub 1 times r raised to n minus 1. We're given a sub 1 is equal to negative 8. Let us solve for the common ratio. R is equal to 4 over negative 8. This is equal to negative 1/2. We can verify by getting the ratio between negative 2 and 4, and that is negative 1/2. Since we're looking for the nth term, n is equal to 10. So we have a sub 10 is equal to negative 8 times the common ratio raised to 9. That is from 10 minus 1. We know that negative 8 is negative 2 raised to 3. And by rule of exponent, negative 1/2 raised to 9 can be written as negative 2 raised to negative 9. Applying product of two exponential expressions, we have negative 2 raised to negative 6, or this is equal to negative 1/2 raised to 6. We have an exponential expression with an even exponent, so this will be equal to 1/2 raised to 6, or 1 over 64. Problem number 8. The 8th term of a geometric progression is 243. If the 5th term is 9, what are the first 3 terms? For our suggested solution, let us use the nth term of a geometric progression. If 243 is the 8th term, then we have a sub 1 times r raised to 7. Let us have this as equation 1. Then if 9 is the 5th term, we'll have 9 is equal to a sub 1 times r raised to the 4th power. This as equation 2. For our solution, let us get the quotient between equation 1 and equation 2. So we have 243 divided by 9, that is 27. Also, a sub 1 r raised to 7 divided by a sub 1 r raised to 4. A sub 1 over a sub 1 is equal to 1. And r raised to 7 divided by r raised to 4 is r raised to the third power. Now, if we will get the cube root of both sides of this resulting equation, we'll get r is equal to 3. The cube root of 27 is 3. Let us solve for a sub 1 using equation 2. 9 is equal to a sub 1 times 3 raised to 4. We have 9 is equal to 81 a sub 1. Dividing both sides by 81, we can get the first term as equal to 9 over 81. So if we are to get the first three terms, we can simplify the first term to be 1 over 9. To get the second term, we just multiply this by the common ratio. 1/9 times 3 is 1/3. And the third term, 1/3 times 3 is 1. So the first three terms of this geometric progression are 1/9, 1/3, and 1. Number 9. Insert 6 arithmetic means between negative 5x plus 2 and 2x plus 3. For our suggested solution, let us illustrate what the problem says. If we are to insert 6 arithmetic means between these given two terms, we have negative 5x plus 2. Then next to this are the 6 arithmetic means. And then 2x plus 23. These terms form an arithmetic sequence. If that's the case, negative 5x plus 2 is the first term, and 2x plus 23 is the 8th term. Using the formula for the nth term of an arithmetic sequence, we have a sub 8 or 2x plus 23 is equal to a sub 1, which is negative 5x plus 2, plus n minus 1. In this case, we have 8 terms, so we have 7 times d. Simplifying this equation, we have 2x plus 5x, 7x, then 23 minus 2, using addition property of equality, that is 21, then we have 7d. Dividing both sides of this equation by 7, we get x plus 3 equals d. So the common difference is x plus 3. To get the 6 arithmetic means between these two numbers is to add x plus 3 to the previous terms. So we have negative 5x plus 2 plus x plus 3, that is negative 4x plus 5. Then add x plus 3, that will be negative 3x plus 8. Again, add x plus 3, that will be negative 2x plus 11. And then we have negative x plus 14. Negative x plus 14 plus x plus 3 is 17. Then we add x plus 3, that will be x plus 20. We can verify whether our answer is correct if we add x plus 3 to x plus 20 and get 2x plus 23, which is correct. So the 6 arithmetic means between these two given values are negative 4x plus 5, negative 3x plus 8, negative 2x plus 11, negative x plus 14, 17, and x plus 20. Number 10. Give a geometric mean between 81 and 1296. For our suggested solution, let us use the formula for a geometric mean between two numbers. The geometric mean between two numbers is the square root of these two numbers. Let a and b be the two numbers. So 81 is a and 1296 is b. Then we have the square root of 81 times 1296. The square root of 81 times 1296 can be written as 3 raised to the fourth power. Let us try to get the prime factorization of 1296 divided by 3. This is 432. Divided by 3 again. This is 144. Divided by 3. This is 48. Divided by 3. This is 16. So 1296 is 3 raised to the fourth power. And we know that 16 is 2 raised to the fourth power. Again, let us rewrite this as 3 raised to 8. That's 3 to the fourth power times 3 to the fourth power times 2 to the fourth power. Hence, the geometric mean is the square root of the product 3 raised to the fourth power times 2 squared. And this is 81 times 4, that is 324. Number 11. Find m and n so that m plus n, 3m minus 2, m plus 7n, and 3m plus 4n are terms of an arithmetic sequence. For suggested solution, let us use the definition of an arithmetic sequence where each term is obtained by adding the common difference to the previous term. So the difference between the second term and the first term must be equal to the difference between the third term and the second term. So the difference between the second term and the first term must be equal to the difference between the third term and the second term. Let us simplify this equation. 3m minus m is 2m. We have negative 2, then minus n. On the right hand side, m minus 3m is negative 2m. Then we have plus 7n plus 2. Further simplifying, we have 4m, that is adding 2m to both sides of the equation, minus 8n, and then add 2 to both sides, we'll have 4 on the right hand side. Let us have this as equation 1. Also, the difference between the fourth term, 3m plus 4n, and the third term, m plus 7n, must be equal to the difference between the third term and the second term. Simplifying, we have 3m minus m is 2m plus 4n minus 7n. This is equal to negative 2m plus 7n plus 2. Again, adding 2m to both sides, we'll have 4m. And then, subtracting 7n, that will be negative 3n minus 7n. So, we have negative 10n equals 2. Let us have this as equation 2. Subtracting equation 1 by equation 2 will eliminate the variable m. We have 4m minus 8n equals 4. And then 4m minus 10n equals 2. Negative 8n minus negative 10n is 2n. 4 minus 2 is 2. Then we have n is equal to 1, dividing both sides by 2. Let us use equation 1 to solve for m. We have 4m minus 8 times 1 is equal to 4. We have 4m is equal to 12. That's subtracting 8 from both sides. Then m is equal to 3. We can check the answer if we substitute m equals 3 and n equals 1 to each of the given terms and find out if they form an arithmetic sequence. Number 12. Consider the numbers from 100 to 500 that are divisible by 13. Letter A. How many are these numbers? Letter B. What sequence is formed by these numbers? For our solution, let us start with letter A, and the smallest number that is divisible by 13 above 100 is 104. So A sub 1 is 104. And the largest number less than 500 that is divisible by 13 is 494. So A sub n is 494. We can solve for the number of terms in this sequence using the nth term of the arithmetic sequence using d is equal to 13 because these numbers are divisible by 13. So we have 494 equals 104 plus n minus 1 times the common difference, which is 13. 494 minus 104, that is subtracting 104 from both sides of the equation, we have 390 equals n minus 1 times 13. Dividing both sides of this equation by 13, we have 30 is equal to n minus 1. Then add 1 to both sides, we'll get 31 is equal to n. Or n is equal to 31. Hence, there are 31 numbers from 100 to 500 that are divisible by 13. And letter B, the sequence formed by these numbers is an arithmetic sequence, and the common difference is 13. That will be all. Thank you for watching. Please subscribe for more math contest drills for Filipino Kids videos.